bit can have two states. It's either a 0 or a 1. This is called base 2 because the space can only be one of two symbols, 0 to represent 0 and 1 to represent the number 1. Now if 0 is the number 0 and 1 is the number 1, how do you represent 2 in base 2? Since we have no more ways to arrange these two symbols, we have to add an extra symbol and arrange them like this, 1 0. 3 becomes 1 1. 1 bit can only represent two numbers. Since there are no more unique ways to represent bigger numbers, we have to add another symbol. Two symbols can represent four numbers because there's only four unique combinations of these symbols, 0 0, 0 1, 1 0 and 1 1. That's 0, 1, 2 and 3. This is exactly what we do with the numbers 0 to 9. It's just that we have 10 unique symbols, so we can represent bigger numbers with less symbols. It's the same idea with base 2, but when you have less symbols to use, you have to use more of them to represent bigger numbers. Like for example, 10 in base 2 needs more symbols than 10 in base 10. The rules of binary addition are 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and if you add 1 plus 1, you need to bring down the 0 and carry over the 1. In this example, 1 plus 1 is 1 0, which is the number 2, which makes sense since you've just added 1 plus 1. Now, using our rules again, let's add 2 plus 1 or 1 0 and 1. First, 1 and 0 is 1. Since there are no more symbols here for 1, 0 is implied and this becomes 1 plus 0, which is 1. And we know from before that's 1 1, which is 3. If you want to get better at this yourself, you can download my calculator in the description. It shows you what numbers the bits are and does these calculations for you. And if you found this video useful, downloading that really helps me out. There's other binary operations it does as well. For instance, AND. When you AND two bits, 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, and 0 and 0 is 0. For OR, 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1. For exclusive OR, both bits have to be different for it to be a 1. So 0 XOR 0 is 0, 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 1 is 0. My app also does these operations as well, and I created a game element in it as well, and I'm trying to see if that's a useful tool to help people understand these concepts. So if you're new to this and you're learning it for the first time, try it out and let me know if you find it useful. So why did I just do a video on bitwise operators in a video about binary addition? Anytime you want to describe bitwise operators, you have to use these diagrams. If you replace the ones and zeros here with true or false statements, what you have is a truth table. And truth tables have a far more broader impact than what you're seeing here. Like, it's important to understand truth tables if you're a programmer to create basic logic. It's important for mathematicians. You often see them in the beginning chapters on books on discrete maths. They're a really important tool for critical thinking. And to me, it's really interesting to see these tools that have this clear mathematical operation being able to abstract out into kind of almost the realm of language and linguistics and this kind of like higher level form of problem solving. I'm going to get a bit abstract here, so instead of saying bitwise operators, I'm just going to say truth tables. So I often see these truth tables coming up alongside binary addition because of the types of algorithms I talk about on this channel here. And it always feels a bit weird to me that like binary addition just doesn't stretch out to that kind of like linguistic or problem solving domain. So I've been thinking about this for some time, so I just want you to have a look at this. If you replace the ones and zeros here with true or false statements, what does it mean when you actually add two truths together? And I think what this is saying is something like, when you add two truths together, the possibilities of your world gets a little bigger. Now, I'm not like a philosopher. Now, I'm not a philosopher or a scientist or anything like that. I can't tell you if that's a true statement. But I thought this was like an interesting pattern. And it really hit me hard because, the older I get, the more I start to realize how little I actually know and how rare two truths might actually be.